Hi friends, today we are going to learn procedure to solve spring problems. Okay. So we know that a spring is an elastic member, okay, which tends to deflect under the action of some external loads, and it will regain its original shape when the load is removed. Okay. So spring is also known as a resilient member, okay, because it has a capability to store that strain energy. So, okay, let's solve the problems. Okay, before solving the spring problem, we need to remember some terminology and some formulas related to mechanical springs. So, what are the important formulas? What are the important formulas needed to remember while solving spring problems? What are the various formulas? Okay, now I will show you that formulas, what are the various formulas required to solve any spring problem, basic spring problem. So actually according to the JNTK syllabus, okay, so mechanical problems actually, mechanical springs problems actually divided into some number of parts, okay, like so first model, so shear stress problems. Shear stress problems. Okay. So this type of problems is completely based on shear stress experienced by a spring. Okay. So using that formula, we can solve any mechanical spring problem. And second model. Okay. Second model in mechanical springs. So second model is energy storage capacity problems. So energy storage capacity problems, it is based on that energy storage capacity U. So that formula U, energy storage capacity is denoted by U. So okay, and see, in third model, next model, problems based on fluctuating loads, and finally problems on leaf springs. Okay, so you can expect this type of models in your final exams, especially JNTK, okay, syllabus. So totally 4 models నుంచి మీకు ప్రాబ్లమ్స్ రావచ్చు. Okay, so total 4 models: shear stress problems, energy storage capacity, and fluctuating load problems, and problems on leaf springs. So ఈ 4 types of models నుంచి మీకు ప్రాబ్లమ్స్ వస్తాయి. Okay, so today we will discuss model A and model B problems. Okay, I will tell you how to solve this type of problems, how to take that given data and how to solve step by step. Okay, I will give you the step by step procedure. Now let us see what are the formulas we need to remember before solving these problems. Okay, thank you. Okay, so let us see what are the important formulas to solve mechanical springs. Spring index, the first formula, spring index. Spring index capital C is equal to mean coil diameter by wire diameter. Okay, so this spring index is actually defined as the ratio of mean coil diameter to the wire diameter. So mean coil diameter denoted by capital D. So again, mean coil diameter capital D is equal to di plus d naught by 2. So di means inner diameter of the coil plus d naught. D naught means outer diameter of the coil. So divided by 2. So we will get mean diameter. So formula for mean coil diameter, D is equal to di plus d naught by 2. Okay, and okay, so here spring index C is equal to capital D by small d. Small d means wire diameter. Okay, pitch again another formula. Pitch P is equal to free length by n dash minus 1, where n dash is equal to total number of turns or coils. So next, maximum shear stress in helical compression springs of circular line. So maximum shear stress. So actually there are two cases here. Maximum shear stress without considering curvature effect. Maximum shear stress without considering curvature effect, and maximum shear stress with considering curvature effect. Okay. So two formulas. Two cases. You can say two cases. Case one. Suppose we are not considering that curvature effect. Then the formula to maximum shear stress tau maximum is equal to Ks into 8Wc by pi d square, where Ks is equal to shear stress factor. Shear stress factor is equal to 1 plus 1 by 2c. Suppose with considering that curvature effect. Suppose we are considering the curvature effect, then the formula becomes tau maximum shear stress is equal to K into 8Wc by pi d square. Now where K is equal to wall stress factor, the K is equal to wall stress factor, the K is equal to 4c minus 1 by 4c minus 4 plus 0.615 by c. So the next formula, deflection of helical compression spring. The deflection delta is equal to 8Wc cube n by GD. Okay, where G means shear modulus or modulus of rigidity, and n where n is equal to number of active coils. Okay, C means spring index, and W means axial load. And fifth formula, energy stored in helical springs denoted by capital U. So U is equal to of W into delta. So of W into delta. So how we get this W into delta? I will explain now. Okay, I will explain now. So U is equal to, U means energy storage. Okay, amount of strain energy stored in helical spring. So let us see how that strain energy stored in a spring becomes W into delta. So how to get this relation? Okay, so this relation ela vachindadi manam chuddam. Okay, U is equal to of into W, where U is equal to energy stored in a spring. So energy stored in a spring, U is equal to W into delta, where W is equal to axial load and delta means deflection. Okay, let us see how to derive this relation. Okay, simple. So let us consider a helical spring which is subjected to some axial load W. Okay, so due to this axial load, okay, spring will deform. Okay, it will deflect. Okay, so the deflection is delta. Let us say this deflection is produced by this axial load W. Okay, so E W load valla vachina deflection enta manaki ikkada delta. Okay, then so W into this delta. Okay, so now, so how to get this relation? U is equal to half into W into delta. Okay, so this ela vachina relation chuddam. Now let us plot. Okay, let us plot a graph between, so this deflection delta. So let us take deflection on x-axis and load W on y-axis. Okay, so x-axis మీద మనం deflection తీసుకున్నాం, y-axis మీద load తీసుకున్నాం. Let us say the load, so this the axial load is applied gradually. Okay, so gradual గా load apply చేశాను నేను ఇక్కడ from, so the load is this axial load, okay, is applied gradually. Okay, so gradually means it will increase slowly. Okay, so from some 0 to some W. Okay, so due to this gradual load, okay, so let us say this point A. Okay, and so due to this load, due to this load W, it will deflect. Okay, it will deflect. It will deform. So the deflection is, let us say this is the deflection. Okay, so due to this load W. Okay, so ఈ లోడ్ అప్లై చేయడం వల్ల మనకు సమ్ సో ఆ లోడ్ అయితే మనం అప్లై చేస్తాం. ఓకే, ఆ లోడ్ అప్లై చేయడం మనకు వచ్చిన డిఫ్లెక్షన్ ఏంటి ఇక్కడ? సో లెట్ us denote this point with B. ఓకే, సో W లోడ్ మనం అప్లై చేసాం, ఒక స్ప్రింగ్ లోడ్ అప్లై చేయగానే అది డిఫ్లెక్ట్ అయింది. సో ఎంత డిఫ్లెక్ట్ అయింది? సమ్ పాయింట్, సమ్ వాల్యూ. ఓకే, సమ్ డెల్టా. ఓకే, ఈ లోడ్కి ఈ డిఫ్లెక్షన్ వచ్చింది మనకి. ఫైన్. నౌ ది ఏరియా So let us, this line is known as load deflection line. Load deflection line. Load deflection line. This line is known as load deflection line. So now the area below this load deflection line represents the strain energy stored by spring, or energy stored by a spring. So area ఏమవుతుంది మనకి, సో ఎంత ఎనర్జీ స్టోర్ చేస్తుందో స్ప్రింగ్ ఆ ఎనర్జీ అవుతుంది మనకి, ఓకేనా. సో ఈ ఏరియా అవుతుంది మనకి ఎంత ఎనర్జీ స్టోర్ చేసింది స్ప్రింగ్, ఓకే. సో లెట్ us make the it looks like triangle, okay. So now take this point A, okay. So now from triangle OAB, okay. So this energy becomes the area below this load deflection line, okay. So is the strain energy stored by a spring. So energy stored by a spring. So U is equal to, okay. So area of a triangle, okay. So this it becomes it look like triangle OAB. From triangle OAB, area becomes half. Okay, what is the formula for triangle? Half base into height. Okay, so half. So this is the base. So what is the value of this base? Okay, so this distance becomes delta. Okay, deflection delta into height. Okay, so you can say in other words OB into, so base OB, height AB. Okay, now half OB means delta, okay, deflection delta. OA means, so this distance OA means load. So let us say applied load is W. Then the formula U becomes U is equal to half load into deflection. So ఎలా వచ్చింది ఆ ఫార్ములా.